Hello guys, Dr. AJ is here.
So the example we have today is for the following results of sieve analysis, find D10, D30, and D60. So what are D10, D30, and D60? D10 and 30 and 60 is basically the diameter of particles that is equivalent to percent finer of 10%, 30%, and 60%. Sometimes it's called the effective diameter. So this is just something to remember. Here in this example, basically, as you can see, we have 5 columns, and everything is basically given to us in order to determine D10, D30, D60. In the test, there is a chance they're not going to give you column 4, the cumulative soil, or they're not going to give you percent finer. But I doubt it. Here in this example, I'm going to basically teach you how to find the cumulative soil and how you're going to find the percent finer, in addition to how we're going to determine D10, D30, and D60. So we start the solution by first determining the cumulative soil retained, even though we have it, but this is just to teach you how you're going to find it. Really simple. All what you need to do is basically use column 4 and column 3, the soil retained and the cumulative soil retained. That's what you're trying to determine. How? So you put the number from here. So for example, the first one is 0. It is 0. There is nothing cumulative yet. So 0 stays 0. How are you going to determine the 20? Really easy. So you put 0 plus, when you go diagonal, plus 20, you're going to get 20.8. How are you going to determine the 70? Is 20 plus 49, you're going to get the 70. The 173.4, it is 70 plus 103. You get 173.4, and so on. The number at the end is very important, the 450. This is basically the total cumulative soil retained on the sieves. This is what the total number. This is very important. This is basically you're going to use it to determine the percent finer. Now, how are we going to determine the percent finer? We know, again, this is something given, but if and only if you were asked to find the percent finer, this is how you're going to determine that. You will use the total from the cumulative, and that's what we have here, 450 minus the 20.8. Basically, it is equivalent to what sieve number you're trying to find the percent finer for. For example, for the first one, you put here 0. 450 minus 0 over 450, you're going to get 100. If this one was not 0, because this one was not 0, you're going to put whatever you have here, and you will determine that, multiply it by 100, definitely, because it's percentage, and that's what you're going to get. For example, the 95.38 is here. How are we going to determine that? 450 minus 20 over 450 is 95, and so on. So as simple as that, that's how basically you're going to determine the cumulative and how you're going to determine the percent finer. In order to solve the question, we need the percent finer and we need the opening millimeter. So basically all we need is just 2 columns. And now I'm going to tell you why do we need those columns. I'm sure you're not going to draw anything in the test, and there's a significant chance they're going to give you this and ask you to determine D10, D30, D60 out of this plot. But how do you draw that? That's something pretty as well. It's really easy and important, I would say. Really simple. Your y-axis is the percent finer, and your axis is the vertical particle diameter. It's basically your opening. But be careful. Log scale. It is a log scale, and it's the opposite way. It doesn't go from 0 to 10. It's the opposite, from 10 to 0. So those numbers, the dots, basically the green plot, is basically the percent finer we have for the soil. So if we go, for example, with 100, so we go 4.75, this is the axis, this is 4.75. We go all the way up to the 100, that's the first dot. The second, we go 95.38. It's very close, 95.38. And then what's the opening 2? Right? So this is basically, this is 1, this is 3, this is 2. We drop it here, this is the second one. And we move on, move on until the last one. We got 0.08, which is very close here. This is 06, 01, around here. And then we got 7.31%, a little bit less than 10%, which is a little bit less than 10%. Right? So now we have the plot, and it's very, very important because you're not going to be able to find the D10, D30, and D60 if you don't have this plot. How are you going to determine the D10? We said D10, it's the diameter that is equivalent to percent finer of 10%. So we come here to the y-axis, the percent finer, and then we go all the way. We hit the plot, the curve, and then we reflect back on the x-axis. The number we're going to find here on the x-axis, it is the D10. The same we're going to do it with D30. We come here, this is the 20, this is the 40, this is the 30%. We go all the way, we hit the curve, and then we reflect back on the x-axis. So between 0.01, 0.03, I would say 0.2, 0.19, this is something close. Again, same thing we do it with the D60. So as a result, we're going to get 0.09 for the D10, very close, D30 0.19, and 0.43 for D60. By the way, it's approximate. No one is going to tell you to waste a lot of time to find the exact number. So with that, we have these basically are the options we have, A, B, C, D. I need you here to be careful and pay attention. For example, the first one, D10 is 0.05. This is not the right one, so we can ignore it directly. But the second one, D10 0.09, close, 0.19, that's true, and D60 as well is the same. So B is the right answer, but if you do it really quick, you might just go D10. For option D, you're going to see D10 is 0.09, D30 0.19, and also we have that, but the last one is 0.4. What I need you is just to pay extra attention and not just quickly pick the one you think is right. Make sure you match the number with the results you got. So with that, we know the correct answer is B. So it's really simple, something common in the exam, and just you need to pay a little bit attention. Nothing's going to be complex in the test, and all of it is like really simple, basic, based on principles and how much do you understand these principles. So example 2, we're required to find the coefficient of uniformity, coefficient of gradation, C sub C, and sorting coefficient. Most likely you're not going to get all of them in the test, but I would say you're going to get 2 or 1 of them. The most common ones for civil engineers, coefficient of uniformity, coefficient of gradation. You're going to get those all the time. Sorting coefficient, it's mostly for geological work, but there is a chance you're going to get it just because it's different, because all the time they're going to bring C sub U, C sub C, so there is a chance they're going to bring C sub O. D10, 25, 30, 60, 75, those are given, and we basically going to use them to find the C sub U, C sub C, and C sub O. Very simple, and you just right away you just plug in numbers and you can get the results. C sub U, D60 over D10, and it's going to give us 4.57. C sub C is D30 squared over D60 times D10. Also, very simple mathematical equation, you can get 0.89, and S naught is basically D75 over D25 and the square root and everything. So you're going to get 1.98. Those are unitless. Everything with D usually is in millimeter. I doubt it, they're not going to give you something in inch for this one, but just in case, always pay attention to the units. C sub U, C sub C, and S naught, they're all dimensionalized. So with that, thank you very much, and we'll see you next time.